Welcome to Calvince Online Math. Let us look at this nice question. Calculate 81 raised to power 1 over log of 3 to base 5 plus 27 raised to log of 36 to base 9 plus 3 raised to power 4 over log to base 7 of 9. So the first thing we're going to do is make sure that the powers are not in fraction. So we're going to do away with the fractions using what we call change of base. So according to the change of base, if you have 1 over log to base a of b, that is the same as log to base b of a. So that is what we're going to apply here. So we're going to have 81 raised to the log of 3 of 5 to base 3, that is. Then for the second one, there's no need for change of base. It is just 27 raised to log of 9, log of 36 to base 9. Then we can apply change of base for this one. So this is the same as 4 times 1 over log to base 7 of 9, which we can write as 3 raised to power 4 times the log of 9, log of 7 to base 9. So the next thing we're going to do is we want to use what we call the fundamental property of logarithms, where we want to make sure that this base and this base are the same. So let us do that. So for the first term, we can write 81 as 3 raised to power 4. Then it is raised to log to base 3 of 5. Then the second one, we can write 27 as 3 raised to power 3. And that is raised to power log to base 9 of 36 plus this one here, we can just have it as 3 raised to power 4 log to base 9 of 7. So for the first case, we can actually achieve the fundamental property of logarithms. We can just switch these powers because it will mean the same thing. So we can write it as 3 raised to power the log to base 3 of 5 raised to power 4 plus this second one, we can simplify the log because if the powers of the base and the powers of the numbers are the same, then we can use the basis of the two. So we're going to have 3 raised to power 3 raised to log to base 9, which we can write as 3 squared, and 36 you can write as 6 squared. Plus this one, we can also switch the same way we did with the first one. But remember, we want the bases to be the same, the base here and the base here. So we can split this power into 2 so that we only have 3 raised to power 2. Then we leave the other 2 out so that we have 2 log to base 9 of 7. So now for the first one, it is already okay, but we can manipulate the second one. So look at this. This is raised to power 2 and this is raised to power 2. So we can as well take 3 and 6 and leave the powers because they're the same. So we're going to have 3 raised to the log to base 3 of 5 raised to power 4 plus this one is going to be, we can switch the powers. We can write the log first, then the inner power later. So we have 3 raised to the log. And like I said, because these powers are the same, we can just take log to base 3 of 6. And then there's this 3, which you can raise that to. Plus, here we have 3 squared, which can be written as 9. And it is raised to power 2 times log to base 9 of this. So you can switch. You can write the log first. That is log to base 9 of 7. And then we raise that to the inner power, that is 2. So now, according to the fundamental property of logarithms, if you have a number a and it's raised to log to base a of a number n, then that is the same as 9. so long as the bases are the same. So this is what we're going to apply for these three expressions. So for the first case, we have 3 raised to log to base 3 of 5. So this is the same as 5 raised to power 4. So for the first one, we have 5 raised to power 4. Plus for the second case, there's 3 and there's 3. So it means this is 6. So it is 6 raised to power 3. And the last one, we have 9 and 9. So it means the value of this according to this property is 7 and it's raised to power 2. So 5 raised to power 4 is 625 plus 6 raised to power 3, which is 216, plus 7 raised to power 2, which is just 49. So when you combine these, you're going to get this to be the same as 890. Thank you for watching. Please don't forget to subscribe.